Welcome to this video on introducing Z sub alpha notation. Let's begin. After watching this video, you should be able to use the notation Z sub alpha. Disclaimer, if you have not already watched my video on standardized inverse normal distributions, please watch that first. Introducing Z sub alpha notation. The notation Z sub alpha, or Z alpha, is used to symbolize the Z-score that separates the upper alpha percent of values from the lower 1 minus alpha values. So here's a picture of the normal curve. So we are cutting this normal curve into two pieces. The area to the right of this z-score, which we don't know the z-score, we just know the area to the right of it is alpha. And then, of course, since the area under the curve in total has to add up to 100%, then this area, the unshaded region, would be 100% minus alpha percent, or 1 minus alpha. So again, as I've already implied, the symbol right here that kind of looks like an A is called alpha. The symbol is the lowercase version of the first letter in the Greek alphabet. Standardized normal distribution, inverse normal distribution using Z alpha notation, example 1. Find the value of Z sub 0.42. This is an inverse normal probability problem. We can also express this problem by saying, what is the z-score that separates the top 42% of the area under the normal curve from the rest? So to visualize this, we will use the stock image. Notice it's not drawn to scale, but again, the Z sub alpha is this value that is cutting the normal curve into two pieces, and we know that the area to the right of this curve is 42%. So let's use our guru to find this area. So in our guru, we're going to click on probability simulation, and then we're going to click on probability, probability calculator, and continuous. So the first thing that we need to change is we need to click on this second dot here, because we know the probability, we know the area under the curve, and we want this calculator to generate the z-score for us. So you might notice when you toggle from the left side to the right side, one thing that changes are the options in your drop-down menu, and I discussed that in greater detail in my inverse normal distribution video. So we want to select the option upper tail because we know that the area to the right of this z-score is 42%, or 0.42. So we want upper tail and 0.42, and then I always like to select this graph option so that I can see what I'm looking at. And when we do that, we can see that the that the z-score that separates the top 42% from the rest is about 0.2, not exactly, but about 0.2. So again, I've reproduced the picture here, and so again, as you can see, the z-score is about 0.2. So it rounds on the graph, and it gives you a little bit more precision up here. So let's do another example. So another way you might see this expressed is find the value of Z sub alpha if alpha is equal to 0.09. So again, it's still an inverse normal probability problem. Okay, and what they're telling us is that the area to the right of the z-score, which we don't know yet, we know that the area is 0.09, and we want to find what is this z-score. Where do we have to cut the normal curve in order to have 9% of the area to the right of the z-score? So let's use our guru to do that. So we already have the normal calculator open. So all I have to do is just change this value to 0.09 and hit this button again. Okay, and again, this picture is reflective of what I want. I wanted to know what z-score cuts this into two pieces so that 9% of the area is above the z-score, and it is not exactly, but it's about 1.34. So again, you can see that the z-score is about 1.34. So now that you watched this video, you should now be able to use the notation Z sub alpha.